G'day, my name's Craig Roberts. I'd like to show you my 5-step procedure for setting up a theodolite over a mark. Surveyors need to set up instruments like theodolites or GPS antennas or EDM targets many times in a day, so I want to make sure that I teach you a way to do it and get it right every time. There's two things we need to be careful of. We need to make sure that the instrument's both level and exactly over the survey mark. So let's look at a theodolite. We essentially have 3 foot screws here that we can manipulate up and down to make sure that the instrument is level. We have some bubbles which can tell us how level the instrument is. We have a bullseye bubble, which is a coarse bubble, and we have a more accurate plate level bubble that we can use. To make sure that the instrument is set up over the mark, we have what's called an optical plummet. This is essentially a right-angled prism. We can look through this and look at the survey mark and set ourselves accurately over the mark. On the optical plummet, we actually have 2 motions. One motion makes sure that the crosshairs inside the optical plummet are sharp, and another motion makes sure that we can adjust the image onto the mark. Now, if we look through and move our head around and notice that the crosshairs move with respect to the ground, that's parallax, and that's bad. So we need to manipulate these 2 dials to eliminate any parallax. A theodolite is essentially 2 protractors mounted orthogonally. So here we can see one vertical circle, and here we can see a horizontal circle. We can lock the circle and move it using these tangent screws. So I can move the instrument like this, lock it, and move this tangent screw for accurate pointing. Similarly, I have a vertical screw which I can lock and move the telescope. The telescope, like the optical plummet, also has 2 dials, one for focusing on the object and one for focusing the crosshairs to eliminate parallax. So that's essentially our theodolite, and now I'm going to tell you my 5-step procedure for setting it up right every time. Okay, this is the tripod, and firstly a few tricks with the tripod. We undo the strap, then we unscrew all of these locking screws down the bottom. And you'll note that the legs are telescopic. Sometimes they stick. People are all of different height, so I think a trick is that if you lift the telescope up, lift it up to about your nose level, and then do the screws up. That'll make sure that when you set the tripod up, it's not too high or too low for you. I'll spread the legs fairly broadly so that it's nice and stable, and now we'll move over to the instrument. Instruments always come in colourful boxes, but one of the hardest things is to remember how to put the theodolite back in the box if you're setting up for the first time. So when you take the instrument out of the box, take a moment to remember how to put it back in. And at this point, I also want to stress that a theodolite or a total station is a precision instrument. So you need to be careful when you use it. Don't force any of the dials, and certainly don't drop the instrument. Let's put it on the tripod. Notice when I place it on the tripod that the top of the plate is triangular, as is the bottom of the total station. Triangles fit on triangles. I also never let go of the top. You can screw the thread into the bottom of the instrument firmly, and we're ready to start the first step. Okay, step 1 is probably the hardest step to complete. We need to get the theodolite approximately over the mark and approximately level. So to do this, we can line the optical plummet up opposite one of the legs. Lock it off with the horizontal tangent screw. Now when I look through the optical plummet, I only see about that much of the ground. So rather than chase over the grass looking for the survey mark, I can place my foot here, look through the optical plummet, picking up two legs, and find my foot, and then track to the end of my foot and place the legs in the ground. I want to make sure that the plate is fairly level. I notice that I'm about 1 centimetre away from the mark, so I'm fairly level, so now I'm ready to step my legs in the ground. And that's the end of step 1. In step 2, what we want to do is put the crosshairs exactly on the survey mark. And to do that, we use the foot screws. We simply move the foot screws and the crosshair will move exactly onto the mark. Now the crosshairs are pointing exactly on the mark. And that's the end of step 2. At the end of step 2, we made sure that the crosshairs were pointing exactly to the survey mark, but the instrument's not level. So we need to level the instrument in order to make sure that we're both level and pointing to the mark. But if we move the foot screws, we move the crosshairs off the mark. So we level with the legs. We use our left hand, place on the leg like this, and unscrew this locking screw here. Be careful because the instrument's heavy. Make sure you don't drop it. I look at the bubble here and I move it. I move the leg so that the bubble goes into the centre of the bullseye. You may have to move a few legs in order to get it right. How do I know which leg to move? Well, if I look at the bubble, you can imagine there's a line which goes through the centre of the bullseye bubble pointing to one of the legs. In this case, the bubble is over towards this leg, so I'm going to level this leg. I touch it up to make sure that the bubble is exactly in the centre. Am I still over the mark? I'm still pretty good. How does that work? I just moved the legs, yet I'm still pointing my crosshairs over the survey mark. Well, the way I like to explain this is you could imagine a sphere which comes over this setup. And in the centre of the sphere is the survey mark. When I move the foot screws, as in step 2, I'm pointing tangentially to the sphere, to point to the mark. When I move the legs, I'm sliding to the top of the sphere, so that I'm both level and pointing to the mark. And that's the end of step 3. At the end of step 3, we made sure the instrument was pointing over the mark accurately and level using the bullseye bubble. But that's a coarse bubble. Now we're going to move to the plate level bubble. And we're going to accurately level the instrument with a more sensitive bubble. So I line the plate level axis with any 2 foot screws. So you can see a line through these 2 foot screws. I line the plate bubble along that line. Now, using these 2 foot screws, I move them in equal and opposite directions. Remember, this is very sensitive, so move it slowly and carefully. Equal and opposite directions, I move the bubble to the centre of the divisions. Once I've done that, I turn the instrument at 90 degrees and I use the remaining foot screw to level the bubble. I can look through the instrument too to see the bubble. Once I've done that, the instrument should be level in all directions. I guess the principle behind this is 3 points make a plane. So with the first 2 foot screws, we levelled the instrument this way, then we turned the instrument at 90 degrees and used the remaining foot screw to make the instrument level in all directions. And that is the end of step 4. So for step 5, the last step, we just need to make sure that the instrument is exactly over the survey mark. Because remember, in step 4, we moved the foot screws by a slight amount. And every time we move the foot screws, we move the crosshairs off the mark. So, as our last step, I can look through the optical plummet and I note that I'm slightly off, 1 or 2 millimetres. So, I can unscrew gently the plate, not completely, just enough so I can slide the instrument. I place my hands at the base of the instrument, not touching the foot screws, and I slide ever so gently so that the crosshairs are now lining up exactly on the survey mark. I always make a quick check on the level too to make sure the plate bubble hasn't moved. It's important in this step that you slide the instrument and don't rotate. The plate here is not level. The instrument is, and it's compensated by the foot screws. So we have a situation like this. If I rotate the instrument, it will go out of level. If I slide the instrument, it will remain in level. I make some final checks. Am I exactly over the mark? Yes. Am I exactly level? Yes, I am. And I can check at 90 degrees. It always takes a while for the bubble to return to the centre of the divisions. And now I've set up my theodolite exactly over the mark and exactly level. I'm ready to start doing some survey work. If you follow that procedure, you'll never have a problem with setting up an instrument.